Welcome back, students. So, in this juncture, we will gonna be talking about the lesson 6.2, which is all about igneous rocks. So, a while ago, we are done talking about the rock forming minerals, the different types of minerals, its physical properties, and also its chemical properties. So, in this lesson, you should be able to first identify and differentiate the types of igneous rocks. Second one, describe the origin and environment of formation of igneous rocks. So, the rocks surrounding a campfire do not usually melt. Rocks need a very high temperature for it to melt. Igneous rocks that need high rock melting heat similar to the temperature of the primitive earth. The term igneous comes from the Latin word ignis, which means fire. It is formed in a temperature not lower than 700 degrees Celsius. So, how can a geologist differentiate one type of igneous rocks from the other? Okay, so let's discuss further the different characteristics and attributes of igneous rocks. Now, minerals such as quartz, feldspar, pyroxene, olivine, amphibole, and mica are the components of all types of igneous rocks. Studying this rock type is like studying magma, since igneous rocks comes from cooled magma. Aside from the temperature of the magma, pressure also contributes to the formation of igneous rocks. Igneous rocks are formed from solidification of magma or lava, which flows out from depth. So that means once the magma came out from a volcano vent through volcanic eruption, then it will become lava, which solidifies and then forms into igneous rocks. So there are two types of igneous rocks based on the temperature pressure condition during the solidification of magma. So we have here extrusive and intrusive. In addition, the time duration is also the factor in the formation of crystals of igneous rocks. So let us deal this different formation and type of igneous rocks in detail. Now, formation of igneous rocks. Igneous rocks are characterized by intergrowth of crystals and volcanic glass. So that means there is a growth that is happening, there is a crystal formation that is happening once an igneous rock is created. So we have here crystal size. So crystal size is actually an indicator whether a rock is formed deep within the earth or just near the surface. So by using the crystal size, we can identify if ang kana nga certain type of igneous rocks na form siya beneath the earth's surface or they are formed on the earth's surface. So that means na ay mga igneous rocks class nga ma-formed on the below the earth's crust, then mayroon ding mga igneous rocks na ma-form just on the surface of the earth's crust. It is directly proportional to the cooling rate of magma. So this means that when the crystals are big, kung dagko daw mga crystals sa isa ka igneous rock, it denotes that the rock is formed underground, since the magma has a longer trip to the surface, giving it longer time to cool down at a very slow rate. On the other hand, if magma cools quickly or fast cooling siya near the surface, that causes the formation of smaller crystals since it is given few time to form. So, kung ang isa daw ka igneous rocks class, the characteristic of its crystal size are big. So, it denotes nga kadto siya nga certain type of igneous rocks, they are formed underground. So, wala siya sa surface sa earth or wala siya sa surface sa earth's crust. Instead, they are formed underground. So, making a longer trip to the surface, so giving it a longer time. So, meron siyang enough time to cool down and at a very slow rate, kaya maka-form siya of big crystals. On the other hand, if the magma cools so quickly near the surface, so that means if ang isa ka magma or a lava that came out from a vent of a volcano cools down on the surface of the earth kanang sa gawas jud sa atong land surface, so we can expect that it would be fast cooling kasi nga mas malamig yung temperature natin dito sa earth's crust compared sa underground where magma is present kasi nga napakainit ng surface doon sa mantle, doon sa asthenosphere. So, if this igneous rocks or if this magma cools quickly or belongs to that fast cooling magma, now the formation of crystals are actually smaller in size. So, mas maliit yung crystal formation ng mga magma na nag-solidify sa Earth's surface compared sa mga magma na nag-solidify beneath the Earth's surface or yung sa underground. Kaya nga merong crystals or merong igneous rocks na may malalaking crystals tapos meron din mga igneous rocks na may mga maliliit lang na mga crystals. Okay, so these are the categories of the different types of igneous rocks. So we have, we've already mentioned that igneous rocks can be identified as extrusive or intrusive. Now when we say extrusive igneous rock, that means that the magma or that means that the igneous rocks actually solidifies on the surface. So that means nakagawas siya during a surface, and then in this surface or also the magma cools down, making it from the word extrusive. So that means nakagawas siya sa surface sa isa ka volcano. On the other hand, the intrusive igneous rocks, they are the one that solidifies on the underground or on the or beneath the Earth's surface. Kaya nga meron silang large crystal grow and then slow cooling lang din sila. Compared sa extrusive igneous rock, they have fast cooling. So mas madali lang silang naga-solidify, and then they have a smaller crystal size compared sa intrusive igneous rocks na low cooling sila. That means dugay sila mag-solidify, dugay sila mag-formed into rocks. So kaya meron silang mga malalaking crystals. Okay, so an example of a large crystals can be shown in a diorite. So the one with the large crystals is a diorite. So diorite is a good example for intrusive igneous rock. On the other hand, the one with the smaller crystals are obsidian or is an obsidian. Now, obsidian is a type of um, extrusive igneous rocks. So, diba, by just observing the different qualities of each of these two types of igneous rocks, we can say nga si diorite, since it is an intrusive rock and then it has a low cooling, so maka-form siya og dagko na mga crystals. So, diba, just by looking, maka-determine ka nga na ay coarse or the grains are actually bigger in size na nag-connect or na nag-attach sa iba't ibang grains then. On the other hand, obsidian, since obsidian is an extrusive igneous rock, so fast cooling siya, so that means dili maka-form kaayo og large crystals ang iyang structure, but instead smaller crystals lang kasi nga fast cooling siya. So just by looking on the physical characteristic of obsidian, we can say that it has, or the surface or the internal structure of the obsidian is actually smooth, not coarse, or wala siyang mga malalaking crystals, but instead it has smaller crystals, making it smooth, glassy looking igneous rock. Okay, now, did you know that the Earth's crust is composed of 95% of igneous rocks? So basically, the rocks that we can observe in our grounds, or the rocks that are being used in the building or making industrialized or residential areas or mga real estate properties, they are actually igneous rocks. So we have here the Bowen's reaction series. Now, crystals form when magma are cooled. A general model is created to show the progression of silicate crystallization at specific temperature. Now, ang pasabot anang crystallization class, that is when a liquid, a gas, or those three types of physical state of matter are being transformed into its solid state. Like for example, water, diba? Since water is in a liquid form, it undergoes crystallization through or in the form of ice and snowflakes. Same also goes with salt, diba? Salt comes from bodies of ocean, and from that liquid state, it undergoes salt crystallization. Kaya nagiging solid table salt, which is ginagamit natin sa ating pagluluto or sa ating kusina. So, Bowen, or it is called Bowen's reaction series, which is actually developed by Norman L. Bowen. So, in the early 1900s, Bowen comes up with the idea by analyzing what minerals were formed if igneous rocks were subjected to varying temperature. So, nagwonder si Bowen class if unsa kay ma-form if ang isa ka type of igneous rocks are subjected to different type of temperature or to different degrees of temperature. So, so in that type of, or in that curiosity, na-create ang Bowen's reaction. So, he started with melting the igneous rocks at about 1200 degrees Celsius, then let the magma cool down giving time for crystals to crystallize. So after doing it, varying temperature, he found out that there are two different branches. The first one is the discontinuous branch. The first one is the discontinuous branch. So according to discontinuous branch, okay. Now the discontinuous branch, so according to this first category, the first mineral, olivine, will form if the chemistry of magma is about 1200 degrees Celsius and has everything that these materials need. So according pa kay Bowen, ma-form daw ang olivine, which is the first material of an igneous rock, if ang temperature is about 1200 degrees Celsius. Tapos, naa daw pud ta ng mga minerals na kailangan para ma-form ang isa ka olivine na mineral. Now, if the magma is allowed to cool down, so if pabugnaw na pud na to og balik ang magma, then olivine will melt and will create pyroxene, which is the next mineral in the sequence. And then further cooling, so once pabugnaw na pud na to si pyroxene, it will form amphibole, and then after amphibole, i-undergo na pud na to siya into further cooling, then mag-form si biotite, and then biotite mica. So, on the other hand, the discontinuous branch or the continuous branch does not include the transformation of different minerals. Because what we can observe manggod along with the discontinuous branch is that on each different stage of temperature and further cooling of this temperature, nagbabago yung type of mineral. So from that olivine, nagiging another mineral na naman, and then further cooling, nagiging iba na naman. So here in the continuous branch, dili siya applicable because according to continuous branch, it does not include the transformation of different minerals. So it only shows the development of calcium plagioclase feldspar to its sodium-rich counterpart. So as it proceeds down the series, the two branches actually merge. So katong discontinuous branch and continuous branch class, mag-merge siya gyapon to siya as it go down to those series of reaction. And the magma starts to crystallize into potassium feldspar, muscovite mica, and quartz. So bali mag-abot lang gyapon sila into certain point. Now to better understand the Bowen's reaction series, let us consider this diagram. So here makita na to ang arrangement or chemical, not really chemical, but the reaction series on the changes of the different types of minerals when it is or when it undergoes further cooling or when it is subjected to different temperature. So we have here, once the temperature is about 1200, so this is for the discontinuous branch, this one. Now once the temperature is about 1200 degrees Celsius, ma-form si olivine. Now if ato pagamayan ang temperature, and then we will subject or reduce the temperature and subject it to further cooling. Let's say gagawin natin 1000, ang ma-form na po na niya class is the pyroxene. And then, once again, babaan na po na to ang temperature niya, magiging amphibole, followed by biotite mecha. And then, once it reaches the lowest temperature, which is 750 degrees Celsius, these minerals could either form potassium feldspar, muscovite mica, and or quartz. Now, for the continuous series of crystallization, the calcium-rich minerals in the form of plagioclase feldspar, they do not undergo this series of mineral changes. So, wala na may tabo nga changes sa iya ha. Basta iya kung unsa ang minerals the moment that it is subjected to its highest temperature, same lang gyapon na siya na minerals na moabot on the on this area. Now, if it is being subjected to its lowest temperature for a certain type of igneous rock to form, then diha pa siya ma-form into either potassium feldspar, muscovite mica, or quartz. And that is the Bowen's reaction series. Basta ang kalahian lang between this continuous series of crystallization and continuous series of crystallization, ang sa discontinuous series na ay alteration on the different composition of minerals as it goes down to different levels of temperature. Compared sa continuous series na kung unsa ang minerals the moment na it is on its highest temperature, maura po na siya ang minerals nga moabot before siya mag-change into certain type of igneous rocks on its lowest temperature. Okay, so here are the detailed explanation on the different types of igneous rocks. So igneous rocks can be classified based on the temperature, pressure condition during solidification of magma. When we say solidification, class, it is the moment na ang molten rock or this molten magma mahimo siyang solid rock, ma-solidify siya, join into its solid state or mahimo siyang solid object or solid rock na magunita nato, na magamit nato. So we have actually we have here extrusive and intrusive. Now, extrusive igneous rocks, they forms when magma or volcanic fragments erupt and solidify on Earth's surface, which result to very fine-grained rock with very small crystals that could not be seen through naked eye. It is also known as volcanic rock. The texture of most extrusive rocks can be in three different forms. We have smooth, full of holes, or it can be large crystals embedded in a fine ground mass. So, sa extrusive igneous rocks class, now, what you should always remember is that extrusive from the word ex, or that means outside, para atong exosphere, na pa ba? So that means as a magma forms or solidifies on the Earth's surface. So wala na siya nag-solidify on the ground or wala siya nag-solidify below the Earth's crust. So that means nag-solidify siya on the surface of the Earth, or naadjud siya sa crust, sa pinakagawas na siya sa atong ground, diha siya nag-solidify. That is why very fine yung crystals niya kasi nga fast cooling siya. because of our temperature here on the ground, which is actually cooler compared to the one underground. Kasi mas mainit doon sa underground. Or kasi mas ano siya, underground has actually higher temperature kasi nga mas malapit lang yun sa mantle, sa asthenosphere, ganyan. Now, example of extrusive rocks are obsidian, andesite, and pumice. Obsidian rock with a glassy structure is so smooth because it cools so quick that crystals were not given time to form. Others such as pumice has many holes from escaped gas, making this rock so light that it can even float. Pumice is a type of igneous rocks that can actually float. Some rocks have a porphyritic texture where one mineral is larger than the rest. The larger one is called phenocryst, while the remainder is termed as the ground mass. An example of this type are hornblende and andesite. So this type of rocks were formed when magma started to crystallize when it is still underneath the Earth's surface, forming phenocryst. While others, the ground mass, they are the one that cools rapidly after the eruption. Yan. So these are the different types of extrusive rock. So we have the one with a smooth surface in the name of obsidian. Meron naman tayong large crystals, andesite, and then pumice, or it is a mixture of phenocryst and a ground mass. Yan. Okay. So, another type of igneous rock is extrusive igneous rock. So, an extrusive igneous rock forms, bakit extrusive? Intrusive pala. So, an intrusive igneous rock forms with magma, crystallizes within the crust. So, that means underneath the Earth's surface ang iyang formation. And is composed of medium to coarse grains. It is also called as plutonic rock. Kanina sa extrusive igneous rock, it can also be termed as volcanic rock. Here in the intrusive igneous rock, it is termed as plutonic rock. So generally, two types of intrusive bodies exist. We have concordant and discordant. So discordant type. When the pre-existing rock bed is cut across by an intrusive body, it is termed as concordant. While if it runs parallel to the bedrock, igneous rocks are actually called as discordant. Now, to better understand what this different classification of intrusive igneous rock means, so let us go over to the diagram here. Ay, wala din diri nga. Alright, so, ang concordant daw, when the pre-existing rock bed is cut across and by an intrusive body, then it is termed as concordant. While if it runs parallel to the bedrock, igneous rock bodies are called discordant. So, here in this scenario, the concordant are this one, itong dike formation na ito. Kasi nga, na-cut across niya ang different bedrocks. Kini siya nga part, and abot siya diri. Same also that goes here. For this one, um, kini siya nga dike. So this one is a concordant intrusive igneous rock. On the other hand, the disconcordant are the one that runs parallel on top of the bedrock. So we have here this one and this one. So nag-run across siya on a certain bedrock. So wala siya ni gawas, but instead kung asa lang to na portion nabilong ang isa ka bedrock, nagpaibabaw lang siya adto or ni attach lang siya adto nga certain bedrock. So wala jud niya gi-cut across ang different bedrock sa Earth's crust. That is the main difference for discordant and concordant. Okay. So, here the concordant, so seals are concordant, while dikes and lacoliths are discordant. Batholiths are large intrusive bodies formed within the igneous or formed within the earth. Alright, so we have here other ways on classifying igneous rock. So igneous rock can be classified based on their texture and their mineral composition. So we have here the different types of igneous rocks based on first texture. So texture muna ang i-discuss natin. So textures of igneous rocks include aphanitic, phaneretic, pegmatitic, vesicular, porphyritic, amygdaloidal, and pyroclastic. So aphanitic rock has crystals that are too fine-grained to be seen by the naked eye or even with the help of a hand lens. So that means they are very fine or very pino kayo siya that even our naked eye cannot be able to see them. And that is the aphanitic rock. Next one is the phaneretic rock, which has grains that are coarse enough to be visible to the eye. So, tama-tama lang yung coarse grained or tama-tama lang gidakon sa iyahang grained for us to be able to observe or for us to be able to see them using our own eyes. Next one is the pegmatitic. I don't know if it's pegmatitic or pegmatitic. Now, pegmatitic rock has crystals that are greater than 3 cm due to very low cooling. So they are more or they are larger compared to phaneretic kasi nga the usual size for pegmatitic rock are greater than 3 cm. So alaki-laki na siya. Next one is the vesicular. So vesicular rock contains tiny holes. So meron siyang mga tiny holes which are called vesicles due to the gas bubbles on the lava or magma. So vesicular basically comes from the bubble formation which escapes when the lava or magma cools down. Next one is porphyritic. So porphyritic rocks have larger crystals that are embedded on smaller crystals. So bali mixture siya between large crystals and smaller crystals. Or bali na ay attachment or ang isa ka large crystals na ay ni-attach sa iyahan na mga smaller crystals. Next one is the amygdaloidal. So amygdaloidal is when vesicles are filled with low temperature minerals after the solidification of magma. So in the amygdaloidal, it still have these vesicles, which is actually um, a bubble formation. However, sa amygdaloidal lang, ang iyaha lang dire is that these vesicles, which are supposed to be empty, filled. Now, diri sa amygdaloidal, ang vesicles niya nanay content, which actually has this low temperature minerals, which are formed after the solidification of magma. Now, next one is the pyroclastic. So, pyroclastic is formed from the consolidation of individual rock fragments that are ejected during volcanic eruption. So, that means it is the aggregation, or it is the combination of individual rock fragments. So, katong mga rock fragments from different types of minerals that are ejected in a volcanic eruptions, they combined or they form aggregate. Then that is why pyroclastic igneous rock is created. Now, the next type of igneous rocks are based on its mineral composition. So, mineral composition na po nato i-consider. Kanina, itong phanetic, phaneretic, itong 7 types of igneous rocks, they're actually rooted on its texture. So, the categorization of this type of igneous rocks are actually based on its texture. So, whether it is smooth or rough road ba siya, or unsa na mga crystal combinations ang naa. Now, here in the mineral composition, we have actually, I guess, 4 types of igneous rocks based on its mineral composition. So, classification of igneous rocks on mineral composition are filsic, intermediate, mafic, or ultramafic. Filsic is an igneous rock that usually have light colored and contains large amount of quartz, potassium feldspar, and plagioclase. It is also called as granitic igneous rock. So filsic rock class, they actually have a light colored mineral composition. Now, the intermediate igneous rock actually has a medium gray or medium green color and consists of major minerals just like amphibole, plagioclase, and feldspar. So, filsic, light colored lang siya. Ang intermediate, it has a medium gray or medium gray green color. Now, mafic. So, mafic igneous rock is dark gray to black colored and is composed largely of plagioclase and amphibole with small amounts of olivine. It is also called as basaltic igneous rock. So basically, kining mafic type of igneous rocks, ano siya? They have dark gray to black colored mineral composition or black colored minerals. Now the next one is ultramafic. Now ultramafic igneous rock has a very dark green to black shade and consists largely of olivine and pyroxene. Now to better remember these different types of igneous rock based on its mineral composition, it is better to identify what are the variation on the color of its mineral. Like for example, filsic, meron siyang light colored mineral. Sa intermediate, meron lang siyang medium gray or medium green. Sa mafic, it has a dark gray or its mineral has a dark gray to black colored. Same also goes with ultramafic, which in which its mineral have a very dark green to black shade color. So, mas dali lang kung i-remember na to ang characteristic on different types of, the characteristic of the colors that this classification have. Okay. So here is an example of or on how you can identify that certain type of igneous rocks or how you can name the certain type of igneous rock. So igneous rock can be named using the binary system, which is mainly based on its texture and composition of the rock. This classification is organized using the table. So these are the different areas wherein minerals are being classified. So what you need to consider first is that the texture. So ano nga ba ang texture ng isang igneous rock? So extrusive ba siya or are they formed on the surface of the earth or are they formed underneath the surface of the earth? So considering also its composition or its silica content or the color of its mineral content. So, feldspar ba siya or light colored? Tapos, intermediate ba siya or mafic? Now, if you are able to identify the texture of the certain type of rock, then you're also able to identify the composition as to whether it's feldspar, intermediate, or mafic. Then you can be able to name the certain type of igneous rock. So it could either be rhyolite, granite, andesite, diorite, basalt, or gabbro. So we have here explanations on how to name a certain igneous rock. So rocks can be classified into extrusive or that volcanic rock and intrusive or the plutonic rock. Extrusive rocks cool so rapidly that crystals were unable to form. Kaya nga, the fragments of its crystals are actually very fine or very smooth, just like the obsidian. This is the reason for their fine-grained texture kasi nga fast cooling lang yung extrusive igneous rock. On the other hand, intrusive rock cools so slow. So, dugay siya mag-cool down and this gives time for the crystals to form, making the texture coarse-grained. So, mas dagko ang iyahang crystal size compared sa extrusive rock. So, in terms of composition, feldspar is silica-rich while mafic is silica-poor. Intermediate is just between. A rock with a high silica is dominated by light-colored. Kaya nga tinatawag siyang feldspar. Kaya nga it belongs to feldspar composition. Light-colored minerals and few dark minerals. In contrast, low silica component rocks have more dark-colored minerals than the light ones. Intermediate rocks have equal amounts of light and dark-colored minerals. So just by observing these two properties, a person can name an unknown igneous rock. For example, the unknown rock has few crystals. So few crystals lang man siya. So that means gamay lang ang iyang crystals or fine-grained siya. So we can assume that it belongs to extrusive igneous rock and has more dark colored man daw than the light one. So that means mafic siya. So referring to the table above, an unknown rock is probably a basalt. So for example, we can say, let's say daw nga, ang isa ka type of rock ay, ano lang siya, have or has very few crystals. So, nanata diri nga point, diri na ta mag-focus, diri na nga area, kay few crystals ang man siya. Now, if the rock has a dark colored, then we can say that it belongs to the mafic composition. Now, if atong idugtong ang iyang classification based on its texture and its composition, then we can identify or we can connect this information, this one and here. So, atong ma-identify nga that certain type of rock is actually a basalt. Yan. So, madali lang kasi itong binary system on the classification of or on the naming of igneous rock. Alright, so that is the end discussion for the igneous rock.